Hello and welcome to a special pop-up stream of Codebase Alpha, and I'm still dissolving, as you can see. So I think this is part of some kind of transport accident I've been involved in, and I'm partially in phase with the universe and partially out phase, so do apologise for this. This is the top I've worn before on stream, and it's been okay, but tonight it's decided to do this. It did yesterday as well. I think it's because I've got it's a yellow top, a yellow jersey with blue screen printing on it, and it seems to have turned a bit kind of greenish and decided to go transparent on me, which is an interesting effect, but it's suitably kind of code base, I suppose, isn't it? We're on an alien code base here, orbiting a black hole, so this is the kind of effect you should expect. So this special pop-up stream is just to start to introduce our next series of projects, which we're going back to do some audio work, and we're going to be doing some synthesizers. So we've already written a synthesizer in WPF and .NET Core 3 with NAudio, the NAudio package, but I wanted to look at something a bit more professional. And you'll remember that we had a short series with Juice and C++. The big problem I found with Juice was that producing the GUIs was a real pain. Spent a lot of time kind of fiddling around with GUI code, and I didn't want to be doing that. There is a drag and drop GUI designer that comes with Juice, but I actually came across something which allows us to do rapid GUI prototyping, and it's called RackAFX. And so we're going to introduce that to you. And we're going to do some programming in C++ as well. We probably shan't do an awful lot of programming today. Certainly won't get any sounds out of a synthesizer. But we'll start to look at the structure of the project and also do a little bit of coding around MIDI signals. So let's pop over into the code, or into our coding stream anyway, so that we can get rid of this weird effect on my jersey. So here we are on my desktop, and I'll go to DuckDuckGo here, and we've got a website here. So we're going to be basing our stream on the work of a guy called Will Perkle, and he's hiya Dragono, welcome to the stream, good to see you. So Will Perkle is an academic. He works in music technology at a university I forget the name of, and he's produced lots of kind of software tools to make learning and teaching digital signal processing and things like that a lot easier. And we're going to be using one of his tools, which is called RackAFX, and it's a kind of rapid prototyping system. Now, if you want to follow along with the stream, then you need to know that there are more than one version of RackAFX. So currently we're on the download page of Will Perkle's website, which is www.willperkle.com, and you can see it's talking about RackAFX 7, and we do use RackAFX 7 for doing some work with audio stuff. So we do use that for some of the plugins, the effects plugins that we've done. We use Juice, so I've converted one of those plugins across to use RackAFX 7. And used it to generate VST3, a plugin, so we can do all that kind of stuff exactly the same as it could be Juice. The problem is that we're going to be working based upon Will Perkle's mammoth book, which is called Designing Software Synthesizer Plugins with C++. And that book, the projects in that book, which we're going to kind of be following along with, they were all written using RackAFX 6. And so that's what we need to download. So when you go to the download, you need to go to Legacy RackAFX 6, and that lives here. Okay, so this is simply an older version. What Will Perkle has done, he's completely rewritten the API which lives underneath RackAFX. So RackAFX 6 is using an older version of the API, and version 7 uses a brand new one called ASPIK, or ASPIC, which is really powerful, and I'm just about getting into using it. I did convert one of I think it was our dimension delay plugin, converted that across to ASPIC, and it's extremely similar to Juice. and the conversion was, there was virtually nothing to do, because we when we built our delay object, it was a fully reusable C++ class, so there wasn't any work to do there. It was just wiring it up, really. So that's all based on this ASPIC API, but the synthesizer projects we're going to be doing are built on this older version. So the latest supported version is this 693, and so there's an installer here. So if you want to follow along, you're going to need to download this one. You can download the other one as well, it's not a problem, but this is the one we're going to actually be using, and they're very similar. In fact, I think that this version 6 does have a few nice features which perhaps are lacking in version 7. In particular, it's got a very nice kind of multi-control, like a LCD alpha wheel type control for your plugins, which looks really nice, and I'll show you that. You do need some other things though. You do need to have CMake on your system, and there are instructions here. There's the URL here for CMake. Not quite sure why one doesn't want to follow that. There we go, CMake. There we are. So you can download that, and there's also some introduction technical notes here which you need to look at and read and follow to set it up. You also need to go and get the VST SDK. So this is an SDK for creating the VST plugins. I've got something strange happening with my keyboard. Let's close that down and start again. Yeah, I've got something weird happening. What's happening? Strange stuff. I'm going to close this down and see what's going on. Yeah, we've got weird stuff. Weird stuff happening. I'm not quite sure what to make of that. Look at that. I've got a stuck key almost, haven't I? Okay. I'm sorry about this. Let me see what I can do in terms of trying to sort my keyboard out. I don't quite believe it. I seem to be... I haven't got a stuck key. There's the V key, it's completely free. Okay, that's most bizarre. Okay, I'm going to stop streaming, and I'm going to restart my machine and start again. So I will be back very shortly. Is that the best thing to do? I can't quite figure out what's going on, to be perfectly honest with you. I don't really want to stop streaming, but I can't do anything with... Oh, there we are, it stopped. There we go. Okay, that's good. Thank heavens for that. Okay, so where was it? Let's go back to Will Perkle's website. Okay. So here we are. That's ASPIC Legacy RackAFX. So download this, download CMake and follow the instructions, and then what you need to do is also go over to Steinberg's website. So if we look at this, Steinberg downloads, and we've got download software, VST, download. Let's try the search box on here. Products, software, VST effects, VST Connect. It's here somewhere. Let's do another search for it. Steinberg VST3 SDK. There we go, developers. So you have to go and download this SDK here, and they do actually ask you to sign a license agreement, and you just send it off, and you never hear another thing from them. You get a message from their support team, and then nothing ever happens. So I've done all that. I've put myself down as a audio hobbyist, and I take it that I'm licensed to use the SDK. There are a few wrinkles with using that SDK. We're not going to use it immediately, and when we come to actually do the conversion of our initial project into a VSD plugin, then we'll go through the process and use CMake to do it. But the structure of the directories is really important. I will show you the setup of RackAFX. Okay, so that's the kind of software downloads you're going to need. So you do need those technical notes as well for CMake, and set CMake up according to that. There's also a link here about setting Visual Studio up. I believe I had to do that as well. So that is, what's that? Can't remember. Here we go. Come on. Okay, so yeah, so this is, you just follow this. It's it's a shortcut, the Control Alt F7 shortcut, which has been removed from standard setup of Visual Studio, and you basically just reintroduce it, and that enables you to do remote rebuilds of Visual Studio projects from within the RackAFX 6 tool. So you just follow those instructions on there. Other than that, I think it's relatively straightforward. Yes, there's the link to the Steinberg SDK, but this isn't the latest version. You need to download the latest version of that. And I think that's pretty much everything we need to know. So let's go and have a look at the actual product itself. So on my desktop here, I've got RackAFX 7 installed, and the 6 is here. So we'll start that up. And they both look very similar when they're started. So what we've got here is our prototyping environment. We've got a whole bunch of slider controls already pre-set up, and we basically click on them and configure them for the GUI controls we need. We've also got banks of switches. Here we've got some input and output meters. We've got an oscilloscope or display here, scope display. We've got this really funky, it's a really kind of back in the day hi-fi kind of control, which is like an alpha wheel which we can spin around, and this changes the options, and here, and then another control here which can change options from within each menu option. So it's like a menu and sub-menu selector. We've got a CPU meter to keep an eye on what we're doing with that. And we've got a whole bunch of really useful tools, including we've got signal generators, we've got impulse generators, we've got filter modelers, all kinds of stuff all built in for us. And it's really, really cool stuff. So if I just show you RackAFX 7, it looks exactly the same when it starts up, but it just looks slightly different when it started. So instead of having all those sliders, you've got many more rotary controls. You no longer have the lovely alpha wheel and the LCD display, but you do have this programmable and extendable bank of buttons. You have a whole bunch of input and output meters. You have a joystick here, which is to model synthesizers which have joysticks. We have some really nice looking VU meters up here for the input and output levels. And you've also got all the same shortcuts as you've got in 6 to do open, load, rebuild, open compilers, clear projects, all that kind of stuff. And you also have the oscilloscope kind of scope feature here. But we're not going to be using that one. We're going to be using this one. Don't know what the best way to. I think it's probably best like that. When you set this up, there's a couple of wrinkles. So the first thing is to go and set up your audio devices. And it took me a while to figure out what these values were. There's a tester you can use, and when you start hearing, basically what you do, you drop a sample or WAV file into a location, and then you can play it. And when you've got your input and output devices set up correctly, then you actually hear the output. Until you do that, you actually don't hear anything, or you get errors. and it did take a little while to get that sorted out. Well, that's just a matter of fiddling with these drop down. I'm not going to touch them, but fiddling with these drop downs here. And as you can see, I'm using WDM drivers for input and output, and these are my Realtek microphone input and my Realtek speaker output. We've got low latency drivers set up, and that's about all we need. I'm not going to touch anything else on there, or even press OK. Then we've got a view here. I think it's view, and then we view preferences. That's right. And this is where we set up all the paths we're going to be using. So I've set up a RackAFX projects folder within my D drive, my D dev drive, and I've also set up a default location to store WAV files that I want to generate or play. You can set a default WAV file that is always kind of loaded up here in the audio file loaded, and you can use for testing. So that's quite useful. And then we've got export directories, and this is where we're going to be exporting our code when we want to build other actual plugins that we can use in DAWs like Reaper or Ableton or whatever. I happen to have I've got the latest version of Reaper installed, and I also have a light version of Ableton. So we've got a couple of different digital audio workbenches that we can play with. The only one I'm interested here, I'm not going to be using AXX SDK or the AU, which is the Mac SDK. We're using VST. And the important thing here is this path. So from the root where your VST SDK is installed, and you can see it's in the first directory down. I've got kind of a top level directory, VST SDK, then I've got VST3 SDK, so that's level 1. I've created a My Projects folder, a Synth Projects, and a Windows folder. And the thing is, it's got to be 4 levels deep from the root. So if this counts as the root here, you need to go 4 levels deep, and it can be called whatever you want really, but VST3 SDK will be already there, and I've created My Projects, Synth Projects, and Windows, and we're going to build our files. When we do an export, they'll be built into there. Then we can open that project within Visual Studio and build, and we can use the CMake commands to actually do all the kind of donkey work about building our VST plugin, and it'll just produce a VST file, and we'll be able to then drop that into Ableton or into Reaper and actually play music. So let's kind of get started. So I'm going to just I'm going to create the project, the first thing we do. So under File, New Project, you can see that we've already got the default project folder created here, and we're going to call this NanoSynth. So this is the first project that we go through in the book. Let's say it's a massive tome. I'll just kind of pick it up and show you, see if we can see it on camera. Get your drink out of the way. So this is the book I'm talking about. It is quite thick, and it's also very large. And you see I've got lots of sticky labels in it, so I can find my way around all of the examples. It kind of starts off with this NanoSynth project, and what the idea of the NanoSynth project is to kind of create a test bed. It's just kind of a starter project where we can create some reusable C++ objects, which we'll use and extend throughout the other projects in the book. And we're going to produce 4 or 5 different synthesizers over the course of this series of streams. Now, it may be that I split the series up and have different subjects kind of in between, but I do hope to kind of go through, because I find all this really, really interesting, and I hope someone out there does as well. It's kind of something. It's something a bit primal about making sounds with your computer, and we're going to be using some kind of top-notch techniques and technologies here. We're not building a toy synthesizer. We're actually building a professional style synthesizer. And we're going to go all the way to using a sampling synthesizer as the very last project. But we're going to build our synthesizers at various degrees of complexity and introduce kind of features that were present in classic synthesizers of the past. But they're going to be modeled in digital world. So we've got our nano synth here. We need to click this output only synthesizer plugin. I think that's all we need to do. We can come back in here and change things if we need to. The company name I've already set up in the system as being Codebase Alpha. And we have some kind of vendor shortcodes, 4-digit or 4-character shortcodes already set up in the system. It tells you how to do that in the documentation for the application. So let's see if we can actually create this project. Okay, so we've got a it wants to create the directory. So what I'm going to do, I'm just going to because I've already kind of created the GitHub repo for this. What I'm going to do is just fool it temporarily. So we're going to go into dev. We're going to go into RackAFX 6 projects. There's NanoSynth, and also I'm just going to rename that NanoSynth to. Okay, and do that, and then we'll create our project. There we go. That's NanoSynth. It's going away and working and starting Visual Studio up for me. Okay, and then we're going to be upgrading to the latest targets. Because of this book was written when I think 2015 was around, so we need to upgrade to the latest Visual Studio. It looks like there's an update to Visual Studio, so we're not going to be falling into that trap. Okay, so let's close this down a second, and then what I'm going to do is I'm going to grab this stuff, copy it across to NanoSynth, and then I'm going to delete the NanoSynth 2 directory. Okay, so that should give us our Git setup. So let's go and have a look at what we got here. So it's created a whole bunch of stuff for us, and this is one of the good things about this system. Very similar to Juice, it produces quite a lot of code for you that you haven't got to worry about. But you still have to do quite a lot of implementation. They say that with RackAFX there's 10 functions you have to implement. We'll be doing a lot more of that because we have to build the basic objects. But there's 10 functions to creating a synthesizer, basically. Okay, so let's go and have a look in Visual Studio and see what we can see. Okay, here we go. Actually, let's just check that we're connected up to GitHub, which we don't seem to be. This is going to ask me for a. This is typical, isn't it? This is going to ask me for. I want to go to Git. What's going on? And we'll do that. We'll do that later. I'll sort out GitHub later. We do seem to be connected, all right. So I think what we should be able to do, if we go to branches, we should be able to link up to our active repositories. I'll sort this out at a later date. It's not an issue for tonight. Okay. As long as I can get this code up into what's going on? Okay, fair enough. No, I'm a bit confused. Okay, let's start again. It's typical when you have an off-the-cuff stream like this, and I thought I had it all planned up. So open the project, nanosynth project, open that up. Okay, just warning us, and here we are. Nanosynth project. I don't want to know about that, thank you. There we go. So here's our files. So what have we got? We've got source files here, we've got header files, we've got resources. A whole bunch of external dependencies which have been brought in for us. There's a few kind of essential files which we're going to need to bring in. So we're mainly going to be working in nanosynth.h and nanosynth.cpp. We're going to be creating some of our own objects, but probably not in this stream. We're going to do a fairly short stream today, and just to get things set up. So if I go across to my D drive and we look in RackAFX, I've got some required files. Now there's a documents directory I've created in here. It's got those CMake technical documents listed in there, and I've also got the complete MIDI specification, version 1 of the MIDI specification, and we're going to be needing to look at that perhaps at some point during the project. In fact, let's have a bit of music while we're working on this part of the there we go. Bit of relaxed styling, that's what we need. Okay. What I've done is I've pulled out the required files that we're going to be needing to use as part of our project. So there's several of these. The plugin constants and plugin objects.cpp should already be present, so let's make sure they are. So we've got plugin constants.h and plugin objects.cpp file there, so they're okay, we've already got those. What we haven't got is lookup tables, the two oscillator files, sys functions and trace, synth functions and trace. So let's have a look what these are. So trace simply gives us a way of tracing output to the Visual Studio output window. So that's all that is. Sys functions, this is a really key file. So there's an awful lot of mathematics you have to deal with when you do digital signal processing. But luckily, all of the mathematics, the conversion of those mathematical functions into C++ code has been done for us, and they all live in the synth functions.h file. And where possible, I'll crack that open, we'll have a look at what's going on. But in some cases it's very complicated stuff, and we probably don't want to go too much into the mathematics on stream. It just loses people, I think. We've got lookup tables. Lookup tables is a very large file, and this is where our wave tables are, and also pre-calculated values. So as we're doing a professional synthesizer, it's all about speed. If we want a high polyphony count, so a large number of notes that can be played at the same time, we need to make this really, really efficient and performant. And so one way of doing that for mathematical functions is actually to pre-calculate all the values and store them in a lookup table. So there's a whole bunch of lookup tables in our lookuptables.h file, and then we've got an oscillator base class, and we'll be using the oscillator base class when we start to build our low frequency oscillator and our two pitched oscillators that we're going to have in our nanosynth. So let's grab lookup tables .h and plugin constants.h, and no, we don't need that one. We need lookup tables and synth functions. Let's go and start another one of these and see where we need to put them. So it looks like they're all mixed into together, so we can just pop them in there. So we want the oscillator CPP and oscillator.h and the trace.h, and the other two files we've already got. We'll copy those. AVX, what's that? Fuel Snable. Yeah, so the lookup tables are for, I think, for relatively we're going to be doing some wavetable oscillators which calculate their wavetables dynamically. Advanced vector extension, is that a C++ thing? That sounds interesting. Let's drop these into the nanosynth project. So we've already got already got oscillator CPP and oscillator H block of it. Let's skip the ones with the same names. Okay, so we got most of the stuff we want in there anyway. It was just the C, the oscillator files and the trace.h file that we didn't have. Okay. So it's in .NET as well. AVX. So we'll have to have a look at that at some point. CP has instructions that allow you to multiply, for example, 8 pairs of floats faster than one pair in one instruction. Okay. So one of the things that we've got with this synthesizer is that we don't call the sine function to get sinusoidal waves. We actually use an approximation, a parabolic approximation for the sine function, because whilst calling one sine function is reasonable, if you want to call the sine function to calculate 800 harmonics from the note A0 all the way up to the Nyquist frequency, then it's very, very intensive. So the whole idea of the setup of the project is really to reduce that kind of stuff. But as we found Fuel Snable, the .NET Core 3 WPF synthesizer, we didn't notice much in the way of performance issues with it. In fact, it was very performant. So, who knows? It might not be necessary. Okay, so let's bring those files in. So we're going to add existing. It's lookup tables, I think it was, or did we already have that? I don't think we did. Lookup tables and oscillator.h. Bring those in, and then we want to bring in our source files. We want to bring in existing item, and we want oscillator.cpp. I think that should be all we need. So we're not going to use the oscillator base class today. We'll look at that probably tomorrow when we start to build some oscillators. Okay, so we've got our basic files in there. So let's have a look around. So what have we got? Let's look at the nanosynth.h file. Okay. So the way this is structured, it's actually structured very helpfully. It's commented completely, almost in the kind of a step-by-step process. There's also some naming conventions which it uses, which I really don't like, but we're going to have to use anyway. So that it uses a kind of a form of a Hungarian notation, but I'm going to have to use it because otherwise it gets very confusing. So for example, pointers, they put a P in front of the variable. Here's an integer, they've got an N in front of it. They use M underscore for member functions and member variables. So it's just one of those things. So Fuel Snable, a modern 4 GHz CPU can perform roughly 200 gigaflops. That means 2 million flops for each sample in a 44.1 kHz stereo sound. Yeah, so it's not something we're going to actually have to worry about. But this is the sample rate of 44.1 kilohertz is what we're going to be using, but there's nothing to say we can't use higher sample rates with the synthesizer. So that's when it starts to get a bit more interesting with the performance. And this is kind of what professional audio software does. It doesn't use the raw mathematical functions. Yeah, GPU, you can plug in that and all kinds. There's loads of stuff you can do, isn't there? So what was I saying? Okay, so what we have to do to implement a plugin or a synthesizer is basically implement these 10 functions. So we need to implement a constructor, a destructor. We need to implement prepare for play, process audio frame, user interface change. There's some optional ones which we won't be touching initially. So there's initialize, which is where we have, this is like one time post create initialization, which we don't do in the constructor. There's controlling the joystick, which we won't be doing till we get to a synthesizer which uses joysticks. Well, what you said there, in the 1990s lookup tables were awesome, is kind of the point, is we're kind of building digital models of 1980s, 1990s synthesizers. So I guess, you know, having those, if the original synthesizer had a wavetable oscillator, we're going to have the option to switch on wavetable oscillators or use Mahone, thank you very much for the follow. Let's have some Electric Elf hype to welcome you to the stream. So thank you so much for that follow. That's really great. So we are kind of building models of 1980s and 1990s classic synthesizers. So say, you know, that we're going to be producing our oscillators are going to be analog modeling oscillators. They're not going to be purely digital in that sense. If they are digital in that they're producing kind of digital signals, but we're going to use techniques to model the analog oscillators which were built into the early synthesizers. Okay, so joystick control. We'll implement joysticks when we come to a synthesizer which has a joystick. There's a couple of things here to do with to processing with buffers rather than frames. We're going to be processing with frames. Then we've got the MIDI controls, and this is what we're going to concentrate on for this stream, really, looking at the actions of MIDI nodes on, off, the mod wheel, pitch bend, and MIDI message. And all we're going to do is create some logging for them. So we're not actually going to make any sounds this evening. I just wanted to get this kind of pop-up stream in place and just to kind of introduce you to the project structure and just get a little bit of code written. Okay, and you can see helpfully there is add your code here. The first thing we're going to need to do, we need to bring in that synth functions header file. So let's pop an hash include file directive in here, and this is going to be synth functions. .h. Okay. Interesting. We've got a weird error that's popped up here. Let's cancel that out. I'll cross that bridge when we come to it. Okay, so we've got our synth functions. Let's go and have a look at what synth functions contains. It's quite a large. You can fix that for me, yeah. What are you complaining about now? Synth functions. Expected a declaration. Well, we'll close that and stop. Interesting. It only start. Okay, well, let's assume that's not a real thing. So what we're interested in here, this has got loads and loads of stuff in it. Lots of constants which have been defined. A lot of these things are to do with MIDI controls, or actually the controls we're going to prototype in the RackAFX GUI. But we're not going to build any of that. So what we're interested in for this evening is this bit. For synth projects, we've got MIDI channels. Okay, so we've got channel 1, channel 2. There's basically 15 channels, and we've also got an all channels thing. Okay, There's all kinds of other stuff in here, including lots of mathematical functions. So we've got, let's have a look what we've got. There's conversions, what's that? Calculate DX amplitude. This is for the DX synth when we write that. It's got, you can see that they're pre-calculated constants. So half of pi, they just put the value in there. So this is all the efforts to actually try to make it more performant. They've even got, there's a fast log base 2 process. There's all kinds of stuff in here. And we'll be referring back to this when we come across the algorithms that we need to implement, see how they're done. There's panning, so this is stereo panning. So there's a whole kind of science to how you process sound between two stereo channels, and you pan between the channels. It's not a simple matter of equally mixing them. There's actually mathematical functions that govern that. So there's all kinds of stuff in here, and it goes on for quite a while, including some nice links out to where the code was gotten from. So you can see here we've got parabolic sine. So this is an approximated sine using parabolas, and you've got a bunch of pre-calculated constants here, a, b, and p, and you do this calculation, and you get a sine approximation for a sine wave without calling the sine function. Okay, so let's pop down to add your code here. So there's a couple of things we need to do. The first thing we need to do is we need to have a variable, a member variable for our nanosynth class for the MIDI receive channel. So this is a uint, which is simply an unsigned integer, and we're going to call this, so this is the convention they use, m underscore for a member variable, u for an unsigned integer, and then just the name. So this is MIDI receive channel. So Rx is pretty standard notation for receive. Okay, so now we can go over to our nanosynth CPP file. We'll tabify that. Okay, and so we need to find where we can do our initializations. So finish initializations here. Here we're going to set our variable we just created, which was u MIDI RX channel, and we're going to set that to be MIDI underscore channel dot all. And I've misspelled it already, haven't I? There we go. And that MIDI.ch.all was defined over in sysfunctions. It's down here. It's this value in the enumeration of MIDI channels. So it just means we're going to be receiving MIDI events on all our channels, all our MIDI channels. Right. So what's the next thing we do? So what we're going to need to do is find our MIDI functions, our MIDI methods that are down here somewhere at the bottom. Let's have a look. Find them. We can find them here. So MIDI note on. MIDI note on. There we are. Okay. So we want to write some code. Currently, MIDI note on just simply returns the value true. Okay. So a lot of the code we're going to write is going to be a bit repetitive. So let's start off. We want to make sure that we are receiving a signal on the right MIDI channel. So we're going to get a MIDI channel in. U channel is going to be our MIDI channel, and if that's not the channel we're processing, then we're going to need to return false here. So what we want to say here is if the M MIDI RX channel, it's MU MIDI RX channel, is not equal to MIDI channel all, I'm going to say and the U channel we're getting into the function is not equal to underscore U MIDI channel received. Then we want to return false. So it's really, we got a guard clause here to make sure that we process the correct MIDI channel. I'll have a quick drink. What we'd like to do now is that when we play a MIDI note on our MIDI controller, we'd like to be able to log something to output, so we can tell that we're actually picking up the MIDI events. So what we're going to need to do that, we need some kind of tracing function, and that's what we got, that trace.h file. So this file, did we include trace.h? I don't think we did. Let's go and grab trace.h. So add existing item, trace.h. There we go. So let's go to the top of the file. Let's say hash include trace.h, and we'll also define a switch where we can switch tracing on and off. So we'll hash define log MIDI and to set it to 1 for being on. Okay, let's pop down to where we came from. So we want MIDI note on. Okay. So here we can say if def log MIDI and in here we want to use our trace feature. So we've got a function called trace, which is defined in the trace.h file. And in there we simply want to put some values. So we could say, we don't have nice string interpolation that we've got in C#. So we're going to say note on. So the channel is going to be %d integer. Note. What MIDI note are we playing? %d. And what is the velocity that we've hit the note with? That's also going to be %d. And then we can have a carriage return after that. And then we need to say we've got what's the first one? The channel. That's U channel. And we've got U MIDI note. And U velocity. Okay. So let's what's the best thing to do here? So if we start this up, we should be able to do this within RackAFX actually. Okay, we seem to be running it now. I'll just reach across here and get my MIDI keyboard. So if you were on the synthesizer streams last time we did work on synths, you'll have known I had an APK25. I think it was a tiny little synth MIDI keyboard. We now got an A49, Roland A49, which is a really nice, fairly budget MIDI keyboard, which I'm learning piano on. So yes, that's our MIDI controller, and let's see if we can get this to react. So let's play middle C. And I don't see anything particularly happening. We need an output window. Where's the output window? View, output. Not showing anything here. Let's stop this and try the debug button here. So I'm not getting anything. I'm getting MIDI reaction here, so RackAFX is picking up my MIDI notes, but we're not getting anything in the output window here. Which is interesting. Okay, so let's have a look at what the code is saying. Let's stop it. So log MIDI is 1. And what we'll do is pop a breakpoint in here and start it up again. So we'll go this route. We're not hitting anything, are we? Which is interesting. Let's try the piano keyboard here. Don't seem to be hitting any of my code. Now, why would that be? Okay, let me put my MIDI keyboard up to one side, because it's a bit of a beast to hold on your lap. Okay, so this is the first issue we're going to have. Oops, what's going on? There's some weirdness going on here. What's it doing? Oh, what's going on? I don't quite follow, viewers, I'm afraid. Where's all these characters coming from? I'm sorry if you're stable, I'm just slightly distracted by the fact that on my stream seems to be in jeopardy here because my keyboard is gone bonkers. What's generating these characters? Not my keyboard. Keyboard's not stuck. I'm very concerned about this. Has anyone come across anything like it? And the keys on MIDI keyboard down. No, the MIDI keyboard is fine. I can unplug the MIDI keyboard. MIDI keyboard's unplugged. I'm still getting that. I'm sorry, this is weird. And it stopped just a minute ago, didn't it? So it's almost as if something has taken control of my keyboard. Stream Deck seems okay. What on earth is causing that? It went away, it stopped, didn't it? Now it came back with a different character. So I'm just checking all my keys. Well, it's a brand new keyboard, so it isn't going to be the keyboard, even though it's generating letters. All these seem okay. It's interesting. Right, I'm going to have to. I did pull my keyboard. I can check it, pull it out and check why it's out. If I can do that, that's a good idea. So the keyboard is no longer attached. And it's still coming through, so it's not coming from the keyboard, which is I pretty much figured it wasn't from the keyboard. Still coming through. Right, I'm going to reboot my machine. So I'm going to just stop the stream for a second and reboot and then come back, and hopefully it'll be fine. So this is going to be a bit weird, but be